Hey everyone. So, kind of to wrap up this unit, I do have just a couple of things I want to talk to you by way of kind of a unit review, and then you'll have the rest of today just to go through the review that you have. Um, Give yourself a chance to practice and give yourself a chance to kind of put it all together and study through all of the concepts that we've talked about together. So, first of all, there's a cute little warm-up problem here. If you want to try it, go ahead, just pause me before I show you the answer. And the answer, if you did it, ended up being Harry was 12 and Sally is 20. Okay. All right. So take a look at this, and we're going to try and simplify this together. What I would want you to see is a couple things. You might want to do what's inside here first before you deal with this 1/2. Like, why apply the 1/2 to everything here when I can see, hey, 50 divided by 2 is 25, and x squared over x to the 4 would be x to the -2, which would bring that down, okay? It doesn't matter if you want to apply the exponent of 1/2 first, that's totally fine. It's just a matter of doing what you see and making sure whatever you're doing it right, okay? So I took this as 25 x to the -2, so that's 2 minus 4 is -2. And then 4 minus 7, because when we're dividing powers of the same base, we would subtract the exponents. And so that gave me the y to the -3. Okay, now I'm going to apply the 1/2. A reminder, when it comes to a base, 25 to the 1/2 is the same as saying the square root of 25. So that would be 5. Then I've got x to the -2 to the 1/2. Well, that's a power of a power, so I will multiply those together. -2 times 1/2 would be -1. That's going to send my x down to the bottom. So I'll have an x on the bottom. Y to the -3 to the 1/2, that would be y to the -3/2. So that'll get sent down to the bottom as well as y to the +3/2. Okay, so my final answer for this guy should be 5 all over x times y to the 3/2. Remember, we've talked in other lessons before. You always, when you're simplifying these sorts of things, you always kind of want your answer to be nice one nice fraction. Okay. All right. So now, just some things to discuss with you. When a is a rational number and n is a natural number, what does a to the 1 over n represent? What I want you to tell me there is when we have a fractional exponent, that bottom number here represents the root index. So you're going to be looking at the nth root of a. Okay. When a is a rational number and m and n are natural numbers, what does a to the m over n represent? Well, again, still the denominator becomes the root index. So we're looking at a, or the nth root of a. But then I want you to understand that that's all to the m. Because the numerator of your fractional exponent just becomes an overall exponent, okay? How can you determine if an entire radical can be written as a mixed radical? So for instance, if I gave you root 90, could I write, whoa, I'm really bad at writing with mouse. If I gave you root 90, could you simplify that? Now, the answer is yes, and the reason that I would want you to be able to say to me right now is I can see a perfect square factor of 90. Because I have a perfect square factor of 90, I can break this down into 9 times 10. 9 would be my perfect square factor, and then the root of 9 would be 3. Okay, so that allows me to simplify. If I compare that to, say, root 65, okay, there is no perfect square factor of 65. If I go through my list, I got 4, I got 9, I got 16. None of those are divisible. I could keep going, 25, 36. Okay, none of those are divisible by 65. And so I can't simplify root 65, where I could simplify root 90. Okay? All right. Now, tell me if it's rational or irrational. 1.21, I would want you right away to say that's rational because it's a terminating decimal. Okay, remember Q stands for the rational family. The root of 49 over 16, well, the root of 49 is 7 and the root of 16 is 4, so that's 7 over 4. The definition of the rational family is a number that can be written as a fraction. That is a fraction. That is rational. Cube root of -root 30, you probably don't know that one off the top of your head. Stick it in your calculator and you see a non-terminating, non-repeating decimal. Okay, there's enough decimal places there that you know it goes on forever and ever and ever. and there's no pattern to the numbers. Okay, there's no repeating pattern to the numbers. Okay, write 40 to the 2 over 3 in radical form in two different ways. So either way you do that, you have to see this denominator of 3 on your fractional exponent. That's going to be a root index. So you've got the cubed root of 40 all squared or the cube root of 40 squared. Either one of those would be fine. Write the square root of 3 to the 5 and the cubed root of 25 all to the 2 in exponential form. Well, the root index here is 2, so this would be 3 to the 5 over 2, and this guy here would end up being 25 to the 2 over 3. Okay? Use the formula B equals 0.01 m to the 2 over 3, where B represents the brain mass and m represents the body mass, to estimate the brain mass of each animal. Round your answer to the nearest hundredth. So what are you given? You're given a moose with a body mass of 512. Well, m represented the body mass, so you're just going to plug that in for m right here. Okay, you can type all of that right into your calculator. If you have a graphing calculator, you can just go 0.01 times 512 exponent 2 over 3. Make sure you do that and make sure you're getting 0.64 kilograms, okay? Otherwise, you're inputting it into your calculator wrong, so you want to try and make sure you are able to get the same answer as me. A cat with a body mass of 5 kilograms, okay, so it's still an m value, so we're doing the exact same thing, except instead of having typed 512, you're going to type 5, so you should get 0.03 kilograms, okay? Okay, so now you're going to work through your review. A reminder as well that you want to make sure you're practicing radicals too. This particular note, I was just kind of putting together the stuff from the unit on your exponential laws and your rational versus irrational. The other big thing here is simplifying radicals, which you have lots and lots of practice on, as well as writing from a mixed radical to an entire radical. Okay, and that kind of sums up the whole unit. All right, have fun. And if you have any questions, make sure you connect with me. Take care, guys.